Welcome class 8. In today's video we are going to learn about images formed by spherical mirrors. So the first thing that we are going to discuss out here is images formed by a concave mirror. So let's take a concave mirror. It has a focus and C as a center of curvature, and when the object is placed at infinity, the rays of light that will come from infinity is considered as the parallel beam of light. And when these parallel beam of light becomes incident at the mirror, they will pass through the focus of the mirror. So when the light intersects at focus, we consider the point of intersection as the point where the image is formed. So over here, when the object is placed at infinity, the image is formed at focus, and the image will be real as if you place a screen on focus, then that screen the image can be obtained on the screen, so it's called real image, and the image will be very small up to the point. Okay, so this is the first case. Secondly, when the object is beyond the center of curvature, then what kind of image will be formed? So let's suppose the green arrow represents the object, and from top of the object a parallel beam of light which is incident at the mirror like this, and another beam of light which passes through the center of curvature. Always we will use, most of the time we will use the parallel beam of light and the light which passes through the center of curvature. Now you need to understand, whenever any ray is parallel to principal axis means this line, if the line or the light is parallel to the principal axis, then it will always pass through the focus over here, or if the light passes through the focus, then it will be parallel to the principal axis. So that is the first condition. And second is, if any light passes through the center of curvature, then after getting reflected, it will again retrace its path back on the same path. Okay, that means if the light is incident passing through the center of curvature, it will retrace its path back and it will move back on the same path. All right, so over here the two rays are passing through. One is parallel to the principal axis, that means this ray will pass through the focus, and this ray will be retraced back. So let's see what happens. See, the parallel light after being incident on the mirror reflects passing through the focus, and the light which passes through the center of curvature retraces back on the same path. So there will be the point of intersection out here. The point of intersection is considered as the point where the image will be formed. So the image will be formed upside down, and the image will be smaller in size. So image is formed between the focus and the center of curvature C, and the image will be real, inverted and small. Next, when the object is at the center of curvature. So when the object lies on the center of curvature, here we'll not use the parallel beam of light, but instead we'll use the ray of light which is incident on the pole. This point is called the pole of the mirror. Okay, and when the light is incident at the pole, in the last class we have learned that it will follow the normal rule of reflection, and it will pass through, making the angles of incidence and angle of reflection equal. So the second ray which will pass through will be passing through the focus. The ray which passes through the focus becomes parallel to the principal axis, and the ray which is incident at the pole will simply follow the rule of reflection and it will get reflected, making these two angles, the angle over here and the angle over here, the angle of incidence and the angle of reflection equal. And when these two rays intersect over here, the image will be formed at this point, but again the image will be upside down, and the image is being formed at center of curvature. Okay, and the image will be real again, inverted. You can see the image is inverted upside down, and the image size will be same to that of the object. Okay, so you can see slowly the image is getting bigger. Over here in the first case it was point small, in the second case it was between the center of curvature and the focus, it was small. Now it is equal to the object size, and let's see what happens next. Next, when the object is between the center of curvature and focus, so the object is coming closer to towards the mirror, and the image is moving away from the mirror. So again over here a parallel beam of light which is going to pass through the focus, and another beam of light which is incident at the pole. The parallel beam of light will pass through the focus after reflection, and the light which is incident at the pole will pass, making this angle of reflection and the angle of incidence and the angle of reflection equal. So it will pass through and they meet at this point. So the image will be formed over here, and look at the image size, it's quite big. It is inverted, but it's quite big and it is real. So the image is formed beyond the center of curvature. Beyond means from far away from here, beyond the center of curvature, and it will be real, inverted and magnified. Magnified means the image will be larger than the object. In the next case, again we move further, closer towards the mirror. The object is at the focus. Okay, so the object lies on the focus. Now, as already been said, one of the ray will be parallel to the principal axis, and the other one will be incident at the pole. So the light which is parallel to the principal axis will pass through the focus, and the second ray of light which is incident at the pole will follow the normal rule of reflection, and making the angle of incidence and angle of reflection equal, it will reflect in this way. But in this case the two rays are not intersecting each other, means the two rays does not meet. So the image formed in this case will be at infinity. So this property of this image formation is used in torches, where the bulb lies on the focus and the light is reflected towards the infinity, so it makes the light travel very far away, and it makes the things visible. Also the headlights of the cars and buses also follows the same principle. Next, when the object is between the focus and the pole, now the object is moving more closer to the mirror. Again, let's take a parallel beam of light parallel to the principal axis. Okay, and it again passes through the focus, and another beam of light that we'll take over here will be passing through the center of curvature, not towards the mirror but away from the mirror. But again this path of light will be retraced and it will move inside the mirror out here. Okay, when this ray moves inside the mirror, we can also trace this light inside the mirror, so that we get something like this. Now these two rays are intersecting inside the mirror, so the image will be formed over there. Looking at the image, we can understand that the image will be erect, means it's not upside down now, and the image is magnified, means the size of the image is much bigger than the object. And also, since it is inside the mirror, it cannot be traced on the screen, hence it is not a real. So when the images are not real, we call them as virtual. So the image will be inside the mirror and it will be virtual, erect and magnified. This property of the mirror, the magnified image formation, is used in the shaving mirrors where the person who is shaving can see properly in detail what he is doing. Okay, so the image formed is quite bigger. Next we'll move on with the image formed by a convex mirror. So here is the picture so that you can understand. So AB is the object over here. Now whether this AB lies very close to the mirror or away from the mirror, all the type of image formation is similar. So the first ray becomes parallel to the principal axis and it follows the rule of reflection and it gets reflected. But the reflected ray over here appears to come from the point F, that is from the focus. Second ray of light, which moves towards the center of curvature, retraces its path back and moves again back on the same path, and here it is getting reflected back. Okay, but when we trace back both the rays, they seem to intersect out here. So the image will be formed over here. Looking at the size of the image, it looks like the image is smaller than the object and it is inside the mirror, so it is virtual, and it is erect, means it is not upside down. So the image will be inside the mirror, therefore it is virtual, it is erect and much smaller than the object. This property of image formation is used in rear view mirrors in the cars so that we can see properly how many cars are approaching from the back. Okay, this mirror is used in rear view mirrors because if you use a plane mirror, the number of images or the image formed in the mirror will be quite small. Quite small means the detail of image that we see in convex mirrors, okay, will be much better than the image formed by the plane mirrors. All right, so this much for today's video. As an assignment, you will be drawing these image formations, writing the detail of the images formed, whether it's real, magnified or inverted, okay, or whether it's a virtual, magnified and erect. All those details you'll be writing in your exercise book. Thank you.